Now let's move on to example 9. This time we are going to solve second order linear non-homogeneous differential equations with constant coefficients, where we have the non-homogeneous term equal to the sum of functions. So let's try to solve this differential equation together. We have y prime prime minus 2y prime minus 3y equals 4 times e to the power 3x plus 5. So the first thing we need to do as usual is to treat this as a homogeneous differential equation by equating it to 0, that is the left hand side equals to 0. So we have y prime prime minus 2y prime minus 3y equals 0. Now we convert this, or we try to derive the auxiliary equation, that is we have m squared minus 2m minus 3 equals 0. We multiply coefficient of m squared by coefficient of constant. We have negative 3. And then we want to find two values that when you multiply you have negative 3, when you add you have negative 2. So that becomes 1 and then negative 3. So 1 plus negative 3 is equal to negative 2. So we have m plus 1, m minus 3 equals 0. We have m plus 1 equals 0, m equals negative 1, and then m minus 3 equals 0, m is equal to plus 3. So we have this to be m1 and then that to be m2. So we can have the general solution to the homogeneous differential equation giving us yc equals c1 e to the power negative x plus c2 e to the power 3x. So this is yc. Now let's move on to find the particular integral. So for the particular integral, we have the function g of x, the function on the right hand side, to be equal to 4 times e to the power 3x plus 5. Now to find the particular integral, we are going to establish yp equals, now because this is an exponential function, then we are going to have, let's say, a times e to the power 3x. Now from g of x, you realize that we have e to the power 3x, and then we still have e to the power 3x in the complementary function. Now so long as we have e to the power 3x in g of x and then also in the complementary function, it means that we can use yp equals a times e to the power 3x, but instead we are going to have a times x. We are going to introduce x, so a times x times e to the power 3x, and then because we have a constant here, we have plus b. So this happens to be the particular integral. Now let's try to find yp prime and then yp prime prime. So that's, we have yp prime, that is equal to, we are going to use the product rule of differentiation here. So we hold ax, we try to differentiate this, we have 3e to the power 3x plus, we hold e to the power 3x, we differentiate ax, we have a, and then because this is a constant, it goes to 0. So representing this in a more presentable way, we have yp prime equals 3ax e to the power 3x plus a times e to the power 3x. So that is yp prime. So for yp prime prime, so we select 3ax, we differentiate e to the power 3x, we have 3e to the power 3x, and then plus e to the power 3x, we differentiate 3ax, and then we have 3a, plus we differentiate this term, and then we have 3a e to the power 3x. So therefore we have yp prime prime equals 9ax e to the power 3x plus 3a, 3a, so 6a times e to the power 3x. So this is yp prime prime. Now from the differential equation, from the DE, we are going to have y prime prime minus 2y prime minus 3y equals 4e to the power 3x plus 5. So that's going to be 9a x e to the power 3x plus 6a e to the power 3x minus 2 times y prime. So we have 3ax e to the power 3x plus a e to the power 3x minus 3 times y. So ax e to the power 3x plus b equals 4e to the power 3x plus 5. So now let's expand and simplify. We have 9ax e to the power 3x plus 6a e to the power 3x minus 2 times 3, 6ax e to the power 3x minus 2a e to the power minus 3a x e to the power 3x minus 3b equals 4e to the power 3x plus 5. Now here we have 9ax, we have negative 6ax, and then we have negative 3ax. So we can cancel out 9ax minus 6ax, that is left with 3ax, and then minus 3ax. So we are left with 6a e to the power 3x minus 2a e to the power 3x on the left hand side. So that becomes 6 minus 2 is 4. So 4a e to the power 3x minus 3b equals 4e to the power 3x plus 5. Now comparing coefficients of e to the power 3x and then the constant. So for e to the power 3x, we have 4a equals 4. We divide through by 4, we have a to be equal to 1. So this is the value of a is equal to 1. And then for the constant, we have negative 3, b equals 5. We divide through by negative 3, and then we have b to be equal to negative 5 over 3. So for the particular integral, which is yp equals a, which is 1, so 1 times x times e to the power 3x plus b, which is negative 5 over 3. So we have yp equals x times e to the power 3x minus 5 over 3. This is the particular integral. Therefore, the general solution to the differential equation is given by y equals, so yc, which is c1 e to the power negative x plus c2 e to the power 3x, and then plus x times e to the power 3x minus 5 over 3. So now let's move on as we solve the next example. So for example 10, we are going to solve the differential equation y prime prime plus 4y prime plus 4y equals 2 minus sine 3x. So we have y prime prime plus 4y prime plus 4y equals 2 minus sine 3x. We are going to treat this as a homogeneous differential equation. So we have y prime prime plus 4y prime plus 4y equals 0. Next, we derive the auxiliary equation. So that's m squared plus 4m plus 4 equals 0. We have coefficient of m squared to be 1, coefficient of constant to be 4. Therefore, we want to find two values that when you add, you are going to get 4. When you multiply, also you are going to get 4. So that's basically 2 and then 2. So we have m plus 2, m plus 2, and that is equal to 0. So we have m plus 2 equals 0, m equals negative 2, again m plus 2 equals 0, m equals negative 2. Let's make this m1 and then that's m2. So since the two roots are equal, they are real and equal, then we have the complementary function equal to c1 e to the power negative 2x plus c2x e to the power negative 2x. So now let's move on to the particular integral. So for the particular integral, we have g of x, the function on the right hand side, to be equal to 2 minus sine 3x. Now you notice that here we have a constant and a sine function. So we have the particular integral yp to be equal to, now here we have a constant, so we are going to take care of the constant. So we have a minus, now since you don't have sine 3x in the complementary function, then that's going to be, you have b cos 3x plus c sine 3x. So let's try to find yp prime and then yp prime prime. Now remember that whenever you have, let's say, sine px or cos px, and if sine px or cos px is not found in the complementary function, then you have yp equals a cos px plus b sine px. Now because we already have a here, then it means you are going to start from b and then c. So b cos 3x plus c sine 3x. So let's try to find yp prime. Because this is a constant, it becomes 0. So minus cos 3x. Now if you differentiate cos 3x with respect to x, then you have negative 3 sine 3x. So negative 3b sine 3x plus, if you differentiate sine 3x, you have 3 cos 3x and then c. So this becomes 3b sine 3x and then minus 3c cos 3x. So this is yp prime. Now let's move on to yp prime prime. So yp prime prime, that's equal to, we differentiate sine 3x, we have 3 cos 3x. So 3 times 3 is 9, and then b and then cos 3x minus, when you differentiate cos 3x, you have negative sine. So this becomes negative 3 sine 3x. So negative times negative becomes positive. 3 times 3 is 9. We have c, and then we have sine 3x. So this is yp prime prime. So from the differential equation given, we are going to have yp prime prime, which is 9b cos 3x plus 9c sine 3x plus 4 times y prime. Now we have y prime to be 3b sine 3x minus 3c cos 3x. So 4 times 3 is 12. So 12b sine 3x minus 4 times 3 is 12. So 12c cos 3x, and then plus we have 4 times y. So we have y to be a minus into brackets b cos 3x plus c sin 3x. So 4 times a will be 4a, and then minus 4 times b will be 4b cos 3x, and then 4 times c will be 4c, and then minus, so minus 4c sine 3x, and that is equal to 2 minus sine 3x. Now let's try to group like terms. Now even before that, here we have 9b cos 3x, and then we have 4b cos 3x. So 9b minus 4b is 5b. So we can have cos 3x, we can have cos 3x, and then we have 5b, and then we have this to be cos 3x. So we can group the cos 3x's on one side, so minus 12c, and then again we have 9c sin 3x, and then negative 4c sin 3x. So if you want to group the sin 3x's, you can have 9c minus 4c, that is 5c, and then we still have sin 3x, so plus 12b. So we've been able to take care of cos 3x, that is 9b cos 3x, 9c sin 3x, 12b, negative 12c. So we are left with plus 4a equals 2 minus sine 3x. Now let's try to compare coefficients of the constant cos 3x and then sine 3x. So for the constant we have 4a equals 2. We divide through by 4. By 4 we have a to be equal to 1 over 2. That is the value of a. Now for cos 3x we have 5b minus 12c to be equal to, now we have no term containing cos 3x, so that should be equal to 0. Hence we have 5b equals 12c. We divide through by 5, and then we have b to be equal to 12 over 5c. So that is the expression for b. Now for sine 3x we have 5c plus 12b. So 12, we have b to be 12 over 5c, and that is equal to negative 1. The coefficient of sine 3x on the right hand side is negative 1, so minus 1. Now let's multiply 5 across for each of the terms. So we have this times 5, this term also times 5, and then this also times 5. 5 cancels out 5. Here 5 times 5 we have 25c, plus this becomes 144c equals negative 5. So 25 plus 144 is 169 equals negative 5. We divide through by 169 by 169, and then we have c to be equal to negative 5 over 169. So this is the value of c. Again, we have b to be equal to 12 over 5 times c, which is negative 5 over 169. So 5 cancels out 5. We are left with negative 12 over 169. So this is also the value of b. Now in that case, for yp, which is the particular integral that is equal to, we have a, which is 1 over 2, and then minus, now b is negative 12 over 169, so negative negative becomes positive, so 12 over 169 times cos 3x, and again for c we have negative 5 over 169, so negative negative becomes positive, so plus 5 over 169 sine 3x. So this is the particular integral. Therefore, the general solution to the differential equation is given by y equals c1 e to the power negative 2x plus c2x e to the power negative 2x plus 1 over 2 plus 12 over 169 cos 3x plus 5 over 169 sine 3x.